Okay, I'm gonna start the stream here. This should be working. Let's go to the next topic here. Okay, let's go through some of the stuff. How many slides are there? One second. There's so many slides. Eventually, I gotta look on this final project stuff at some point. I don't know when I'm gonna do this final project. I did all the quizzes already though, so eventually we'll come to this final project. Release condition did that. I need to go back and do some of these quizzes. Homework 3, I'm almost done. Once I cover this PowerPoint, I will be able to learn a lot more about how to solve homework 3. Let's put test in here in the chat. Test message. Okay. Homework 3 is due next week instead of this week. Yeah, they got pushed back. Final project materials posted. Dropbox folder. I need to apply to some jobs as well. Lots to do. Probability review, maximum likelihood estimation. I wonder if I should stream Duolingo on here at some point as well. I will do that at some point. Maximum likelihood estimation. Oh, my test message hasn't went through yet. Why am I overlay chat? Oh, there it is. Overlay chat is working. Get another live chat displayed somewhere. Okay, maximum likelihood estimation. Probability and statistics. Build statistical models, describe the world. Statistical models of form a representation, some aspect of the world to help you better understand the world, okay? If you collect survey data on customers, you might have a better sense of demographic information, characteristics, preferences. Statistical models, set of statistical assumptions, okay? Hypothesis informed beliefs, okay? Where do understand where these assumptions come from? We have to first have to better understand basic probability, okay? On basic probability, the term outcome loosely refers to something that happens in the world which you care to examine or understand. Yeah. Set of all possible outcomes is called the sample space. Okay. Each outcome in the sample space represents a unique, distinct thing that could happen. Okay. Event is a set of outcomes, set of possible things happening. Want to be able to understand what's the probability of event A happening, what's the probability of event B happening. Okay, an event. Did we go over this? Event A happening, probability of event B. Collected data on customers. Turns out that 500 male and 500 are female. What's the chance of randomly selecting a survey response from a female customer? Okay. Event is select a survey response. Okay. Surround from count. Okay, a bunch of names. Okay. Oh, wasn't there was event? Okay, this is basic probability stuff. Discrete outcomes. Need to add the probabilities of discrete outcomes. Okay, distinct outcomes. Okay. So it's gonna show those rectangle stuff. 1 out of 1,000. 500 distinct outcomes. Oh, interesting. Okay. Sample space. Events of the sample space. What's the probability of event? Areas can represent probabilities. Unique outcomes. This person selected. Okay. Gender of survey respondent. Okay. More data about customers. Leafy greens. Where is the interesting stuff in here? Okay, what else?
Mm.
Mm, 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 mm.
Mm.
Old woman eats leaves regularly. Okay, that's intersection right there. Joint probability 1 out of 8. Hmm. Okay, joint probability, fractional clusters, male, service. Okay. Population says there are more times that you need vegetables, winning water, and getting struck by lightning. Crazy. The set AG is a partition of sample space. The set contains pairwise disjoint events whose union is the entire sample space. Then for any event B, the total probability of B. How's it going, Babs? Your message is going to show up on the screen soon. It's just a bit delayed. Law of total probability. Sample space contains pairwise disjoint events whose union is the entire sample space. For any event B, total probability is equal to the sum of the probabilities. Just eating and chilling, that's good. What you eating? You see your messages on the left hand side of the screen. I figured out how to get those to show up the other day. Then I also figured out how to get there's a bot in here, an 8 ball. There's a bot. Pierogies, that's good. That's good, dude. Let's ask the 8 ball how your pierogies taste. Labs pierogies taste. What else is here besides law of total probability? The 8 ball says never. That's funny. Language of math not meant to confuse you. Okay, let's see if there's something more interesting. Picture proof. Entire rectangle represents sample space. AG partitions the space. What else is here? A1 be the set of people who have high school education. A2 bachelor's degrees. A3 masters. Okay, splitting up A into different partitions. What else do we have to go over? B be an arbitrary event, so B is a random event. Event B overlaps with everything. Take 2. You'll never eat these delicious pierogies. That's funny. Send a pic of the pierogies. Probably spelled that wrong. B overlaps with everything. The area of B is equal to the sum of the areas represent the intersection. Well, there's a bunch of intersections there. Areas represent probabilities. Okay, B intersection A1 plus B intersection A2, A3, A4. If the set A is a partition of a sample space that contains pairwise disjoint events whose union is the entire sample space, then for any event B, the probability is sent to. Okay, cool. Let's go look at your pierogies real quick. Not bad. Not bad. You got a lot of sauce on those pierogies, dude. What is that? Polar Berry Blizzard. Now that drink looks good. That's pretty sick. Cool. Yeah, there's a bunch of calculus here. J, summation, intersection of AJ. What else? Summation notation shorthand for addition across. Different index things. If you have these sets, then this is shorthand notation, okay? Generalizing what is seen, such as survey response from a female cluster is the sum of probabilities, okay? Adding the probabilities of each of the outcomes gives the total probability of the event. Law of total probability generalizes. If you have an event, the probability of the event is the sum of the probabilities of smaller events. Okay. I know there's some stuff on the bakeries. I need to go over the bakery stuff for the assignment. Should I have another drink? But April says perhaps. Yeah, if you want to look up the documentation for how this 8-ball thing works and the bot works, feel free to. I still have to test it out. Could make you a moderator at 1.2 if you want to be. Conditional probability of A given B is defined as this. Don't tempt me. That's funny. I feel like the 8-ball responds better to you than it responds to me. Conditional probability of A given B is defined as this. Okay, woman eat leafy with intersection, eat leafy in the bottom. I don't know where he got these numbers from. Pink and green. Conditional probability for rainstorm. Are you likely to forget your umbrella? Daily return for Bitcoin was negative. How likely was it Ethereum's return for that day was negative? What fraction? I swear this guy put this part in because he probably saw my channel. What fraction of subscribers are male? How would you know? P male given subscriber. Raise of our subscribers means that you should focus attention on subscriber. Looking for P. Yeah. Flipped a coin, told you it landed heads. Does that change your belief of whether or not it will rain tomorrow? If it rains, would that change your belief about whether ATH daily return is negative? Yeah, I don't think there's a correlation between these things. Someone's a subscriber on my YouTube channel, does it change your belief whether or not they're male? Answer is no, then you'd say the events this person is male, not this person's subscriber independent. Yeah, dependency and independence seem to be important. Events E1 and E2 are independent events if P. Sure, I don't mind modding. Okay, that's sick. That's sick. There's gonna be a bunch of stuff to try. So, experimenting the commands. I have to go on Twitch as well at some point, the Pokemon streaming, and see how that works, and install SE Live. Events E1 and E2 are independent if this, otherwise they're dependent events. Conditional probability of E1 given E2 matches unconditional probability of E1, and the events are called independent. Okay, right. So dependent independent events are important to keep in mind. Who's messaging me? Someone messaged me a short. Okay, cool. This is there. More intuitive belief about whether event E1 occurs is not dependent on whether or not E2 has occurred. What other stuff you want to add? I'll show you something. So there's like this alert box thing. If you look on the screen, it should show up at some point. I want to add, like I got the chat working, I got a subscriber count. I want to add like overlays. There's an AI overlay too, but it doesn't always work. And it looks like the alert box is also not showing up, oddly enough. Let's look if the BRB thing shows up. Like I'm testing out different screens and scenes and stuff. So they take time, but I'll send you videos like that are similar to what I want to test out. The BRB screen is not loading for some reason. I don't know why. But I'll show you at some point. The alert box also didn't load either. More bots. Transitions. What else? Cutscenes, intro, outro. I need to add all those things and test them out. And the chat's back. Okay. Think whether or not event E1 occurs, right. What page was I on? Independence. Events are independent, dependent. Never really understood this notation. E1 give E2 intersection over E2. Want to add intro, outro, and connection to Twitch. Oh, once you get a few set up, you can get some really nice automation. Yeah, automation would be good. Yeah, for sure. That would be good to have, definitely. Independent events, intersection. Suppose you flip a fair coin, chance of flipping it seconds right, because each of them have an odd of 0.5 here. Up to the power of 5. Blue's influence. Being blue and being green are not independent events. Careful of confusing disjoint events with independent events. Events in which are believed but one event aren't affected by information from another event. Events that don't overlap in a Venn diagram. Interesting. One of the reasons why students get confused because they inaccurately remember independent events as these events have nothing in common. Interesting. R functions. Doing exploratory data analysis for customer analytics. Conditional probability. Conditional on a trip taking longer than 20 minutes. What's the chance that the user was a member as opposed to a casual customer? Prop table and table functions. Screen is black. Oh, it still hasn't shown up? That's weird. Do I have the BRB screen on? Yeah, I probably had the BRB screen on. Yeah, I probably did come back. This is the ending screen. I guess if I don't shut off the other screens, it doesn't show my main screen back. Yeah, thanks for letting me know. I would have turned the BRB screen off. It's been glitching though for some reason. Table function. Table function gives a table of frequency counts across different combinations of two categorical variables. An example, two categories, number of gears in a car, right? So it was empty cars with gear and empty cars. So they already had this preloaded library. So cylinder and gears, and it's a comparison. And it makes a matrix. Joint and conditional probability tables. Prop table, proportions table function gives a joint. Yeah, this is pretty useful, I think, for the assignment as well. The empty cars dataset shows represent the different number of cylinders in the engine, while the rows represent a different number of forward gears. Prop table. Just using prop table without other parameters, you get a joint probability table. If you add all these numbers, what do they sum to? Right, yeah, and they need to sum to 1 on the rows and the columns. It's also called a contingency table. What's the chance that a car has 4 gears and 6 cylinders? 4 gears, 6 cylinders. Isn't that rare? No, it would be an extra one. And the intersection of that row, oh, actually 4 and 6, yeah, 12.5%. Car has 3 gears, and there was a second car with 3 gears. It's probably going to say that one at the end, maybe. Books in the row label 3, so those represent like each sum, yeah, each of the individual values are going to be summed, okay? Law of total probability, so each of those gets summed. I was totally zoned out in the lecture when he was teaching this. Chance has 4 gears, so you add these rows together. Total probability of second car with 4 gears. Yeah, that makes sense. 5 gears, same things from the rows. Okay. How long have I been on for? It's only been like 20-ish minutes. P3 gears, P4 gears, P5 gears. Adding the numbers here adds to 1. Okay. This is probably from a valid probability distribution. Marginal distribution, because people would write these numbers in the margins of the page. Oh, interesting. Didn't know that. The same way as we had found the marginal distribution for gears, we can also do the same for the marginal distribution for cylinders. P4 cylinders. Okay, 4, 6, 8 cylinders. When people find these values, they would write them below a table in the bottom margin of the page. Joint probability. Okay. Good to know. Good to know. Okay. What else do we have here? Verify numbers found, add to 1. Ask the question focusing on 3 geared cars. What's the chance of seeing a car with a 4-cylinder engine? Focusing on 3 geared cars, they're just asking the same questions. Conditional probability intersection over the total probability for the gears. That makes sense. Intersection is that joint probability over the total. So that's the conditional, okay? Don't have to do these by hand, yeah. I'm stuck to do those by hand. Rock people. Find the conditional difference easily in R. The condition on the rows, meaning to focus on a specific gear value. Then you set your margin to 1. Answer conditional having 3 gears. What's the chance of having 4 cylinders? Focus on one, add the numbers, okay? Columns partition the data into 1 of 4 categories. Sum to 1, y. Look at the first row, okay? Use the definition of conditional probability. Any gear, vehicle. I'm gonna make a YouTube short from Sora as well on R. Let's give it a short. Give me a short on data science and analytics. Okay, let's see what it makes for me. Okay, prop table, finding the conditional probabilities. Numbers add to 1 for each row. Numbers in each row of the conditional probability form a valid probability distribution. Kind of been called a conditional distribution. Probability distribution derived from focusing on a particular condition. Okay. I wonder where he got those numbers from. Prop table. Were they from here? Did he round them up? Also conditional either the rows and columns. Conditional having 8 cylinders. Okay. And use margin 1 or 2. It does not tell explicitly as an alt, but always use the table of non-negative values. Okay. Way you can tell if you have the right margin is asking, am I trying to focus on a specific value of the rows, or am I trying to focus on a specific value of the columns? Okay. I'm going to focus on the specific value of cylinders and add the numbers down a column. The outputs, they should add to 1. Okay. Representing table, don't use the base graphics in this, or quite bad. Okay. You want to be using other packages. Okay. Those are classic passive packages. Probably just for discrete random variable. Okay. Yeah, Poisson distribution is important. Discrete distribution in which the values can be taken on one by one. Many things like the models, values cannot be listed one by one since they can be anywhere in a continuous range. On a down from flooding, monthly profit, time it takes for critical equipment malfunctions. Lasting innovation of probability theorists was the idea of a random variable. Ideas write down a set of possible outcomes or events that can happen. Mapping between the odd and number is called the random variable. Okay. In the case of a discrete random variable, a set of numbers can count as this. In case of a continuous random variable, a set of numbers could be infinite. Okay. Virus, random variables. The reason why the concept of random variables became lasting innovation is because once you tie the outcomes, you can plot the distribution. Right. Distribution of continuous random variable tells you the likelihood that x falls in a range of values. Okay. Same as for discrete random variables. X-axis represents the values the random variable can take on. Okay. Similar to, but not quite the same as discrete random variables on the y-axis. You have something that represents how likely the random variable will be close to that number. Clarify soon. Visual examples of a continuous random variable. Okay, cool normal distribution, rectangle. Yeah, cool. Probability density function. This is important. Instead of bars, we want to represent probabilities in area under a curve. Call it the probability density function. What property should this function have? This function should be negative. Area under the curve. The interval should represent the probability that x lies in the interval. Total probability across the possible realization of the random variable should be 1. Area under the curve should be 1. continuous random variables. In terms of the math, continuous random variable has a probability density function of this. Okay. Uniform distribution. Values can be greater than 1. Exponential distribution. Okay. Probability density function of the same as probability mass function for discrete random variables. We see that fx greater than 1. Okay. Density function of a particular value of x does not represent probability. It depends. This was day 7. I did day 8. Was day 6 the one with the bakery? Because that's the one I need for the assignment. Did Sora...
Data isn't just numbers, it's stories. Patterns hidden in
the this is kind of good.
Buried in the city lights. When curiosity meets collaboration, we turn raw information into decisions that matter. Data isn't just numbers, it's stories. Patterns hidden in the noise, signals. Data isn't just numbers, it's stories. Patterns hidden in the noise, signals buried in the city lights. When curiosity meets collaboration, we turn raw information into decisions that matter. Data isn't just numbers, it's stories. Patterns hidden in the noise, signals buried in the city lights. When curiosity meets collaboration, we turn raw information into decisions that matter. Data isn't just numbers, it's stories. Patterns hidden in the noise, signals buried in the city lights. When curiosity meets collaboration, we turn raw information into decisions that matter. Data isn't just numbers, it's stories. Patterns hidden in the noise, signals buried in the city lights.
Okay, let's see if this short works better now. I'm gonna post it soon. Build a list machinery, discuss the independence of random variables. Want to define and explore the concepts of independence of random variables for 2 reasons. These 2 category variables have a statistically significant relationship. In other words, are they independent? In order to develop the idea behind maximum likelihood estimation, view data points as independent samples of some common distribution. Then we use MLE approach, okay? Events are independent if this, otherwise they're dependent. If the conditional probability of E1 given E2 matches the conditional probability of E1, then the events are called independent events. Okay. Key events. More than halfway there. One event does not change your belief about the likelihood of the other event. Talking about independence of random variables, the concept of the same event that you condition on is a particular random variable takes some value. Okay. Tell if 2 discrete random variables are independent if telling you about the value of one of the random variables does not influence your belief about the other. Conditional probability table. Okay. It's just changing the bottom thing. Then go to each other. Okay. The bakeries. This is what I was waiting for. This was on page 100. Need to write this down. Lecture 7, page 100. A half-baked example. Suppose that for the last 10 years you recorded your daily bakery sales. For good luck at the start of the day, you flip your lucky coin and record whether it was heads or tails. The coin is a fair but lucky coin. Your daily sales are high with 75% probability and low with 25% probability. Have a sneaking suspicion that whenever the coin flip is heads, the daily demand will be high that day. You believe this was because you called many times with the heads as tails. Cereals were high that day. Is there a relationship between your daily sale and lucky coin flip? Although you don't know, say a coin flip has no bearing on the sales outcome that day, okay? Independent stimulate both the daily sales and lucky coin flip using sample function. Daily sales, low and high. Combine these two, head and tails, prob argument. Where's prob? Right there. I'll just change the probability weight. Oh, those are probability weights. Ah, I see. Okay. Based on the way we constructed daily sales and coin flip, you can see that there's no relation between the two. Okay. Sum the joint probability table, table, daily sales, coin flip. Okay, numbers look different than due to the randomness in the random number generator. Idea look the same. Chance of heads. Table. Focus on the first column and add 2 numbers there to find the total probability. What's the chance of tails in a decent table? And you focus on the second column and add the two numbers there to find the total probability of tails. Okay. There's the marginal distribution for the coin flips. Mm. Okay, let's see this one.
Data isn't just numbers, it's stories, patterns hidden in the noise, signals buried in the city lights. When curiosity meets collaboration, we turn raw information into this.
Okay, this is not bad. This one's not bad at all.
Data isn't just numbers, it's stories, patterns hidden in the noise, signals buried in the city lights. When curiosity meets collaboration.
Where's my channel here ready to publish this?
Data is Data isn't just numbers, it's stories, patterns hidden in the noise, signals buried in the city lights. When curiosity meets collaboration, we turn raw information into the. Data isn't just numbers, it's data isn't just numbers.
Okay, coin flips, marginal distribution. Margin equals 1, conditioning on the rows, prop table. Conditional reference for each outcome are roughly similar. Top row and bottom row look similar. Daily dividend high on a given day. The daily amounts low on a given day. Okay. Conditional distribution. Joint probability table. Total chance of seeing high demand would be the sum of across the first row. Total chance of seeing low row, the sum across the bottom row. Okay.
Data Science channel, where I explore data science techniques and fintech projects, along with playing some Pokemon. Welcome to my Data Science channel, where I explore data science techniques and fintech projects.
Not bad.
Welcome to my Data Science channel. Welcome to my Data Science channel, where I explore data science techniques. And fintech projects, along with playing some Pokemon. Welcome to my Data Science channel, where I explore data science techniques and fintech projects, along with playing some Pokemon. Welcome to my data science. Channel where I explore data science techniques and fintech projects, along with playing some Pokemon. Welcome to my data science channel, where I explore data science techniques and fintech projects, along with playing some Pokemon. Welcome to my data science channel, where I explore data science techniques and fintech projects, along with playing some Pokemon.
It's crazy what AI can do. Need to figure out how to make a digital twin as well. That would be kind of helpful. Okay, discrete RVs. What was RV again? I don't remember. All the console sets in a given day, low sales. Conditional distribution. All streets and two random variables are independent. Conditional distribution will match the imaginal distribution for any x and y. Okay. Two random variables are independent. Yeah.